think about it, when prices change, you have a change in supply, or quantity supplied or quantity demanded. So quantity demanded, demand is downward sloping, quantity supplied, upward sloping. You get these functions here, and you don't need to do all this crazy math or anything like that, especially in Excel. All you gotta do, find two observations. If you have the price here, demand and supply, you can graph them and you'll get your functions. All you do is point here, point here, point here, point here, wherever, they could be there. And assuming that it is a linear demand function, basically you're going to add a trend line. So right click, add a trend line, display equation. You got your functions right there. So we'll go here and we'll just do a quick example. Let's say we had these two observations, price of 10 and 20. And we knew the demand was this and that, and the supply was this and that. We'll go into this one later, deadweight loss, it doesn't matter. All we're going to do here is figure out, so we did an equilibrium quantity here. Basically, this is, we took the demand, we took the supply, we made them equal to each other, and we just solved for x. That was it. All we did was add and subtract, multiply and divide. Nothing crazy, just the exact, like, Algebra 1 kind of stuff we learned. So we got an equilibrium of $160.45 for a price. Alright, so let's go 130, 140, 150, 160, 170. And there we go. We have our supply and demand curve. We have our intersection, which, gosh darn it, it is right there. So we have someone who's willing to, at this price, customers are willing to buy 2,100 units of this, or just about, and producers are willing to supply about 2,100 units of the same thing. That price. And this right here, deadweight loss, typically when you have price floors or ceilings, and it represents the gap in between these. So let's say the price is 130. Everybody wants it at that price. It's great. It's a great deal. Who wouldn't want it? It's on sale, fire sale, I don't know. But supply, nobody's willing to do it. In fact, people are saying you would have to pay me to do this. You have to pay me that much to even make me consider meeting that demand. Well, okay. So you have to get that plus that. Eesh. And that's the amount in total with the quantity difference and the supply difference, or between demand and supply, that it would essentially cost, or it's quantified in dollars type of thing. You have this, price goes up to 140, hey, it gets a little better, so right there. Then 130, or 150 I should say. Get to 160, and right here at 160.45, boom. You got supply and demand, deadweight loss is 0. And the deadweight loss is essentially, let's say there was a price cap. Businesses could not sell something for over 130 bucks. Okay, everybody wants it, great. Nobody's going to make it because it's a loss. Let's say you can't produce it profitably at that. Let's say it's the truest reason to not produce it. It won't make money, you'll go out of business. In theory, to meet all the demand, the government would have to subsidize this much, $613,470 to those businesses to get them to profitably, or at least break even, produce that. In reality, it would have to be more, because if you can break even in business, who cares? You want to make a profit. You're going to go into something that makes you more money than that. So there is that. You know, there's other things, argues about utility companies, things along those lines. Anyway, that's a whole another basket of fish there. Here, I just made another random example, just to show you can do it pretty quickly on your own. So I made observations 1 and 2. So we have prices, 190, 190, and supply, because it is an upward sloping and a downward sloping function for supply and demand. Supply, if the price is 100, they'll make 60. If it's 90, they'll make 55. Demand, if the price is 100, people want 35, and if it's 90, they'll get 47. I just picked those numbers at random. I figured it'll give us some interesting functions here, whatever, something we could solve for. When we set those two equal to each other, again, just algebra. So all we did was take basically this. We go 0.5x plus 10 equals minus 1.2x plus 155. So all we did is we took 0.5x plus 1.2x, and then we went 155 minus 10. We made them equal to each other, and the reason we did that, we moved the negative. I usually move the negatives. You can do it either way. I prefer the negatives being turned to positives. So you go here, you move this 1.2x to here, so you got 1.7x. Then you go here, you take this 10 away from here, you got 145. So you have 1.7x minus, or plus I should say, or equals, wow, off today, 45. There you go, and you go equals 145 divided by 1.7, 85.29412. That's our equilibrium price, and there we are again, rounding errors aside. Actually, we can even, there it is. Yeah, see, same thing, rounding error. You go in here, we went 50, 60, 70, 80, and 90. Here's our equilibrium price right there in dollars because we round to the hundredths. And we've got our demand, 52.64 units, 52.64. Deadweight loss, again, you'd have to either subsidize or you have to subsidize to induce production. And then we have, I'm going to get your producer and consumer surplus and all that good stuff, but they intersect, and what we'll do here is find our demand and supply, and we will just graph them. You highlight those, insert, good old scatter plot, and here we are. So we'll go there. Yes. Yeah. And that's pretty much it. So you basically do that. You can change up your charts however you want to do it. You can switch rows, columns, all that stuff. You got pretty much, shoot. Any observations you want to do here, you can get your function again, you can add your trend line, all that stuff. Regardless, just play around with it, see what you like, and that's how you can quantify all your supply and demand stuff in Excel. It's great if you want to say, all right, I'm opening a lemonade stand. Can I sell it at $2? Can I sell it at $2.50? How much do I sell each day? You can add temperature, stuff like that. Really, you can get as intricate as you want or keep it as simplistic as you want, just like this. And at the end of the day, it's just some basic stuff you can do on a calculator. All right, have a good one.